All right, so we're jumping into chapter 1, data analysis, and we're looking at section 1.1 today, analyzing categorical data. So remember those things that get put into groups. There we go. So some learning targets for today. You'll be able to make and interpret bar graphs for categorical data, identify what makes some graphs of categorical data misleading, calculate marginal and joint relative frequencies for a two-way table, calculate conditional relative frequencies from a two-way table, use bar graphs to compare distributions of categorical data, and describe the nature of the association between two categorical variables. So here's that data we had from before. Remember that far side, that preferred communication is a categorical variable. Just to give you some more information, provenance would also be a categorical variable, gender would be a categorical variable, and handedness would also be a categorical variable. All right, but we're going to stick to preferred communication. And the values that are here. Now, values not as numbers, but the possible responses or choices you have for the categorical variable are those values. And that's where the data comes in. It's either in person, Facebook, cell phone, or text messaging. So a frequency table is exactly what it sounds like. You take the preferred method or that variable and you tell me the frequency. So 2 people preferred cell phones, 1 preferred Facebook, 3 preferred in person, and 4 preferred text messaging. So that's all a frequency table is. It has a variable and the frequency. A relative frequency table is, well, relative. It's relative to the whole group or the total. So what it's going to do is it's going to take those frequencies and put them over the total. There's 10 pieces of data here. There's 10 individuals they chose from. And so the relative frequency would be 2 out of 10, 1 out of 10, 3 out of 10, and so forth. So frequency is where the frequency table gives the count. The relative frequency, it gives the proportion as a decimal or a percent. And this is where this number is super important and where stats, see already in the first lesson where the words we use are super, super, super important. All right. If you say the wrong word, then you can lose points on the AP test. So our language is super, super, super important in this class. I know it's a math class, but our language does matter immensely here. So a proportion should be as a decimal or a fraction. A percentage is, as you see, 20%, 10%, 30%, 40%. 40% and 0.4% are very different numbers and mean very different things. So make sure you are very particular in your word choice and you are actually saying what you want to say. All right. So to display this distribution category data, we're going to make a bar graph. So we have the variable down here, preferred communication method, with each group or each category. And then on the left-hand side is actually our percent. So we see 20%, 10%, 30%, 40%. So this bar graph was made from our relative frequency table. It could be, if you use the regular frequency table, instead of percentages, you would want to have the counts. You would have like 1, 2, 3, and 4. But we have the percentages, so we are using the relative frequency. Either works, it's just good to know what you want to do. And it's going to lead me into my first real AP tip that will lead in for the whole year. But you have to label your graphs. If you don't, you're going to lose points. And I'm going to tell you that often. I'll give you tips, so maybe you want to write this down in a different color or whatnot. But you have to label. And so what does labeling mean? Well, it's going to tell me the variable and then these categories here. And on the left-hand side, it's the percentage is my label. Because this graph would look very different if instead of percentages, I had counts or frequencies. The numbers would be all different. If I had frequencies here and kept this as 10, 20, 30, and 40, that means that 10 people said that they prefer Facebook, 20 people said cell phones. That's not the case here. 10% did, and 20% did. So you have to label your graph accordingly. All right. Another possible way to show your categorical data besides a bar graph is a pie chart. And you can see here, 40% is text messaging, 20% is cell phones, 10% is Facebook, and 30% is in person. Now, I'm just going to put this as a disclaimer. It's much better. That's a very bad English. It is. we prefer to use the bar graph over the pie chart. The one thing a pie chart is nice of is it does show you in relation to the whole. So like you could see, hey, 40%, that's a lot compared to the rest of all the other groups. But that's really the only advantage of a pie chart. We do like to use bar graphs a lot more than pie charts. So graphs, good and bad, and I think this is exactly what is going to come into play here. But bar graphs are built dull to look at. Um, it is tempting to replace bars with pictures or to use special 3D effects to make the graph seem more interesting. Don't do it. We're in this stats class, we are not trying to have the most interesting looking PowerPoint that you're giving to a bunch of executives in a business office. All we're trying to do is be very good at statistics. All right. And when you start to make the graphs look pretty or cute, um, it loses sight of some of the data that's going on. And so don't use it. Just be very simple in it. Let the data do the work. You don't need to spice it up at all. So um, the two cautions here, this is another thing you might want to put in that other color, like I was saying, is beware of pictographs and watch those scales. And I think we'll see some examples here. Maybe not. What I would just say is the reason why this picture like this looks so much bigger than these two. And so it can um, kind of taint your idea of what's going on in this picture instead of just let the scale on the side do the work. 100, this is less than 100, and this is maybe between 300 and 400. Just let the scale do the work. You don't need to add this other picture in, making it look so much bigger than it might be, because this picture definitely looks bigger than this. Doesn't look a quarter of the size of this. It looks substantially smaller, and it's not even, it's maybe at most a quarter of the size of this. So that's why the pictures are not always the best thing to use. Right? So analyzing data and two categorical variables. So how do you analyze data? How do you analyze data when a data set involves two categorical variables? So in this case, we're going to look at if you're part of an environmental club and if you own a snowmobile. So if you own, rent, or never. So you can see both of these, hey, they're categorical, right? The options are either no or yes or no. And then the snowmobile is either own, rent, or never ride. Okay, so the question is, how do you use both of these variables? Well, you can use a two-way table, and that's what this is. It is a table of counts that summarizes data on the relationship between two categorical variables for some groups of individuals. I'm sorry, this is not a two-way table. I misspoke there. This is just how we collect our data. But a two-way table is where it shows accounts for both. Down here, this is a two-way table. So it takes this individual, so like here, this person is environmental club no and owns a snowmobile. This one would be like a tally in the no but owns. So this would be the first respondent is one of the 279 people that fall into that category. Number two, it would fall into no but rent, so they would be in this category. The third respondent would be yes and never, so this 212. And that's how this two-way table is created. They had, I think, over 1,500 people respond in this survey or however they collected the data, and each one gets put into this little two-way table. So it's a two-way table because it puts environmental club on top and then snowmobile use on the left. Then we can include the rows and columns. So we can see the totals basically is the only difference here. It tells us how many total, and like I said, there's 1,526 people used in this data collection. So a marginal relative frequency gives the percentage or proportion of individuals that have a specific value or categorical variable. Maybe a little hard, but I think just talking or giving an example. We call them the marginal relative frequencies because they're in the margins, right? If we go back, this is our table. Boom, we add these two columns. This is the margin of the table. That's how I kind of remember it. So the marginal relative frequencies are exactly that. They're the frequencies in the margins. So for example, if I was looking at, and they tell me one specific variable. So inside here, like if I picked 497, that's talking about snowmobile renters and no in the environmental club. So it's two things. All right. But this 1221, that is a marginal relative frequency because it's only looking at one variable. It's environmental club no. So 80% are not in the environmental club. That means that 20% are in the environmental club. 43.1% never use a snowmobile, 37.6% rent one, and 19.3% own. And if you notice anything about here, the marginal relative frequencies always add up to 100%. All right, so if you added these two together, right, because that should make sense because if you add up the categories in the margin, right, that becomes the total. Those two together would be every single person. Every single person either has to not be in an environmental club or be in it. And every individual either has to never use a snowmobile, rented one, or owned one. Those are your only options. So you should, if you add up the marginal relative frequencies for for the column or for the row, you should get 100%. A joint relative frequency gives a percentage or a proportion of individuals that have a specific value for one categorical variable and a specific value for another categorical variable. So, let's see, they give an example. If the marginal relative frequency is just environmental or in here, then the joint relative is something in the middle. So it says what percentage of people in the sample are involved, environmental club members and own snowmobiles. So they're environmental club members, so I know I'm in the yes, and they own snowmobiles, so that would be down here at 16. So 16 people fall into this category out of that 1526. So 1% fall into that category. All right. What proportion of people in the sample are not environmental club members and have never used a snowmobile? So no to environmental club, never used would be 445 out of 1526 or 29.2%. Right, so those are joint relative frequencies. Marginal and joint relative frequencies do not tell us much about the relationship between environmental club membership and snowmobile use for the people in the sample. So a conditional relative frequency gives the percentage of proportions of individuals that have a specific value for one categorical variable among individuals who share the same value for another categorical variable. I think, again, just an example would be easier. So it says, what percentage of environmental club members in the sample are snowmobile owners? So what percentage of environmental club members? So we know yes. And what percentage of those own a snowmobile? So there's 16 of them, but they have to be in the environmental club. So it would just be 16 out of 305. So 5.2% of environmental club owners own a snowmobile. So it's a little bit easier to understand the relationship between those two with this conditional relative frequency. So if we did that for each one, we would build that distribution of snowmobiles among those that are environmental club members. And that's called the conditional distribution of snowmobile use among environmental club members. So here we basically take this two-way table and turn it into kind of the relative, sorry, I want to make sure I use the correct word, the conditional relative frequencies. You can find the distribution of snowmobile use among the survey respondents who are not environmental club members in a similar way. So exactly what we just did, so in this category. So just another way to describe this data. It's all about, these are all the conditional relative frequencies here. Just another way to describe the data. Here's an AP exam tip. When comparing groups of different sizes, be sure to use relative frequencies, which is percentages or proportions, instead of frequencies. We'll go more into depth in class about this, but if there are 100 freshmen and 500 seniors, and you're like, oh, and let's say that, oh, there's 30 freshmen are in favor of a new lunch option, and the seniors are like, Oh, 200 the seniors are in favor of this new lunch option. So we should listen to those seniors because so many of them are done or consider that. Well, that's not a really good comparison just because the purport or the number of people that you're looking at 30 out of 100 versus 200 out of 400. Those numbers are not accurate to talk about the counts. It's more accurate to describe the percentage of those people, so that a larger group doesn't overwhelm or get to control more of the data. Right? And then make sure to avoid statements like more club members never use snowmobiles when you mean a greater percentage of club members never use snowmobiles. Again, that hints just to the one above. The more is just talking about the actual number versus a greater percentage is telling you not only are there more people, but the percentage of them or more people out of the whole actually care about this, which is more important or more useful than just saying um, there are more that do it. So it takes into account that total portion here. All right. So there's a couple ways to show this besides that two-way table into a graphical representation, and we're going to use a variation of the bar graph. So there's two types. A side-by-side bar graph displays the distributions of a categorical variable for each value of another categorical variable. The bars are grouped together based on the values of one of the categorical variables and placed side by side. Where a segmented bar graph displays the distribution of a categorical variable at segments of a rectangle with the area of each segment proportion to the percentage of individuals in the categorical portion category. I think it's easier just to see these than to describe them. So a side by side. So here you have environmental club no or yes, and then the colors or the different bars here, blue, red, and green, are the percentages that fall into this category of no. And this group is the same that fall into the category of no, or of yes, sorry. A segmented bar graph is instead of putting these bars on the side of each other, they're going to stack them. Okay, and this is why the key on the left is really important, and we're talking about percentages here. Notice that this is 100% of no and 100% of yes. And you can see right off the bat, hey, there's more percentage or a greater percentage never use a snowmobile that are in the environmental club than are not. And you can see that just because how much bigger this blue graph is than this one. And then you can see the next two are smaller than the corresponding for no. Um, so it's just another way to show this bar graph. Just be aware that we are looking at the percentage here versus just the counts. A mosaic plot is kind of cool actually also, because a mosaic plot is a modified segmented bar graph in which the width of each rectangle is proportional to the number of individuals in the corresponding category. So in this segmented bar graph, you don't know how many people said no and yes, right? The only way you can kind of compare this is by the snowmobile use, where you compare the height of this rectangle to the height of this rectangle, but you don't know anything about the no or the yes. Same thing with this side by side. The mosaic plot allows you to show that. This one is so much wider, so it means that there's a lot more people that use no versus yes. That's kind of the cool thing about this mosaic plot is it tells you the percentages of both variables, at least roughly for the no and the yes. Um, yeah. So this is going to be a good conversation for class, but um, there is an association between two variables if knowing the value of one variable helps us predict the value of another. All right. We're going to we'll dive more into this of association and kind of, um, we'll just stick with the word association. But when we go into the conversation about correlation or causation, association kind of gets lumped into that conversation as well. But association, all it means is that if you know one variable, it will help you predict the value of another. So if knowing the value of one variable does not help us predict the value of another, then there's no association. So here, there would be an association here because, hey, if you know that they are environmental club member, then it's easier to predict that, hey, they probably never used a snowmobile before. If the distribution looked like this, it doesn't really tell us much. If we knew if they were no or yes, it doesn't really help us understand anything else because the distribution isn't very, so there's no association down here, and there would be an association in the first one. Right? And this is exactly what I was saying. Association does not necessarily imply causation. That will be a very big conversation we'll have in class. Okay? And those are our learning targets for today. So we can make and interpret bar graphs for categorical data, identify what makes some graphs of categorical data misleading. That's the sizing of things, or using pictures or bad scales. Um, calculate marginal and joint relative frequencies from a two-way table. Calculate conditional relative frequencies from a two-way table. Um, using bar graphs to compare distributions of categorical data, and describe the nature of association between two categorical variables.